This video is on absorption and emission and the differences between the ground state and the excited state for electrons. Okay, so the first idea we want to talk about here is that electrons can move between energy levels, okay, in an atom, and the way they do that is by gaining or losing energy. And so there are two processes. One process when the electron gains energy, and then one process when the electron loses or releases energy. And so that's the topics of absorption and emission that we're going to talk about. Okay, so the first topic is the process of absorption. So let's talk about a couple things. Let's pretend that this is hydrogen, and hydrogen has one electron, and here is the one electron in the first energy level. Okay, so I'm going to introduce a new term for us, and that term is going to be the ground state. Okay, and the ground state is it's the electron configuration where the electrons are in the lowest possible energy levels, we'll say. Now for hydrogen, this is an easy discussion because hydrogen only has one electron, and so thus its configuration is 1s1, right? So for hydrogen. In a minute, I'll do an example where we're talking about something that's not hydrogen, just so that we can see a little bit of a difference when we have something that has more than one electron. Okay, but the ground state is basically the normal electron configuration. Okay, it's the one you're used to writing when you follow the periodic table and you fill in the electrons in their orbitals. Okay, so it's the ground state. So what can happen is this electron can jump up to maybe the second, maybe the third, maybe even the fourth energy level. But in order to do that, that electron has to take in or gain or absorb energy. Okay, so what happens is if we pump this electron with enough energy, we might be able to get it to jump up to, let's say, the second level. Okay, now that has to that requires a specific amount of energy, and that specific amount of energy would be the energy difference between level 1 and level 2. Okay, it has to absorb that exact amount of energy. So if we bombard this electron with energy, and that electron is able to take in that energy and then jump up to a higher energy level, this process is called absorption. Okay, so absorption occurs when an electron gains energy and jumps up in energy levels. Now in this case, I only had it jump one level, but it's totally possible that given more energy, that electron would jump from level 1 to level 3 per se. Okay, it would require more energy. Okay, so two new words, which are ground state, we've learned the lowest possible energy electron configuration, and then the process of absorption, which is where an electron takes in or absorbs energy and jumps to a higher energy level. So now we're going to switch to the process of emission. So we're going to kind of take this picture. Okay, so the fact that we're talking about hydrogen, and hydrogen's electron is up here now in level 2, and we're going to introduce a third new term, and that is something called an excited state. Okay, and an excited state is where at least one electron is in a higher energy level than normal. Okay, so we know that if this is hydrogen, hydrogen's configuration should be 1s1. That's its ground state. Okay, but looking at this picture, hydrogen's 1 electron is in the second level. So maybe in this case, hydrogen's configuration is 2s1. Okay, and so that's not the normal energy or the normal electron configuration because it's in a higher than normal energy level. So in this case, hydrogen's electron being in the 2s would be considered an excited state. So that electron, though, does not want to stay in that excited state. It's kind of a stressful situation, okay? It's a higher than normal energy. So what that electron does is it wants to fall back down to the ground state. And in order to do that, it releases energy. And this process is called emission. So emission occurs when an electron releases energy and moves. How about let me change that. And let's say it releases energy and jumps down to a lower energy level. Okay. Now, this energy that is released sometimes we can see it. And that would be in the form of light. Okay, so sometimes we can see this energy in the form of light. Only if, though, it's in the visible section of the spectrum. Okay, sometimes we can't. So it depends on how much energy is released, whether or not we can see that energy. Okay, so actually this is how your lights work. Like when I come into my classroom in the morning and the lights are off. Okay, what has happened is those electrons that are in those light bulbs are in the ground state. Okay, they're just hanging out in their lowest energy level possible. When we flick the light switch on, we're pumping energy into the electrons. Okay, so what happens is we turn the light switch on, energy fires into the electrons and they jump up. We don't see anything, okay, but now they're in that excited state. They don't want to be there, so they fall back down. When they fall back down, right, which is this picture, when they fall down, they release energy in the form of light that we see. And that process continues all day long until you leave and turn the lights off, and then the electrons permanently reside in the ground state and there's no light anymore. Okay, so I bet you didn't know that's how your lights work. One other piece here, let's do, like I said, I wanted to do a excited state for something that was not hydrogen. So let's do like, let's do like lithium. Oh, what happened? So lithium, okay, if you were asked to write the ground state for lithium, remember that just means the normal electron configuration. So lithium's is 1s2, 2s1. Okay, so then if you were asked to write an excited state, there's actually lots and lots of answers here. And I want to show you that there can be more than one. So maybe for lithium, we take one of the 1s electrons and we promote it up to the 2s. So in this case, we'd have two 2s electrons and only one 1s electron. So this is an excited state, okay, because there normally aren't two 2s electrons for lithium. However, notice that I still have 3 electrons total. That's important because I'm not changing how many electrons there are. I'm just changing their placement in the orbitals to get an excited state. Okay, another excited state might be 1s2 and then skipping the 2s altogether. Maybe that 2s electron goes to the 2p. Okay, that's an excited state. Notice again, there's still 3 electrons. Maybe we have an excited state where, technically speaking, could this happen? You have your 2 1s electrons and then we skip the second level altogether and go to the 3s. Okay, that's an excited state. So there's still 3 electrons. So The point is, the ground state is the normal electron configuration, where the excited state, there can be lots of examples as long as you've taken at least one electron and put it in an energy level that's higher than normal.